Hello, my name is Andrea Lamoureux, and today we're going to go through an example relating to the concept hypothesis test of the mean. And here we have our spreadsheet, just a little helpful chart here to use when tackling future hypothesis test problems. It shows when to use a two-tailed test and when to use a one-tailed test. The symbol here represents population mean, and the M represents a specified value. So just a little reference to use if questions come up on whether to use a two-tailed or one-tailed test in the future. Today we are going to go through an example relating to a one-tailed test. Here I have my sample data set. The question reads, a company is developing a new speedboat. In order to justify the price marketing wants, the boat needs to be very fast. Specifically, the mean time to finish the standard test course should be less than 55 seconds. To test it, the boat operator will race the course 8 times. The boat operator's times selected at random are as follows. And these are representative of the times. So question, should they market the new speedboat? Assume assumptions and conditions for appropriate hypothesis testing are met for the sample, and assume a significance level of 0.05. So here I have my mean that I calculated in Excel, and here's the formula bar if you have any questions as to how I generated a specific value. So used the average function, selected my data, standard deviation below here, so standard dev, and then selected my values. Sample size is 8, and I have my significance level here of 0.05, null hypothesis 55, level of significance again listed in my chart. Sample size is 8, sample mean, so I just moved my values here in a little data table so it's easy to reference those cells when going through the formulas down below. So standard error of the mean. So here I divided my sample standard deviation by the square root of my sample size. And I have listed the equations out to the side as well for better viewing and assistance. So degrees of freedom, that's n minus 1. N is 8, so 8 minus 1 is 7. T statistic, here I took my sample mean and subtracted the value for null hypothesis 55 and divided that by my standard error of the mean and come up with negative 1.909. So lower tail test, lower critical value. Here's my equation for this here, and I also have it written out on the side. And p-value. Here's my equation for the p-value here. And calculated out, we get 0.0489. So with that value, we reject the null hypothesis. Lower than the significance level of 0.05, which causes us to reject the null hypothesis. So the t-distribution value, I have 0.0489. Here's that equation here. Use the t-distribution function and notice the absolute value. Make sure that you put that in there of my cells. And then 1 minus my value here, and we get 0.95108267. So that is hypothesis test of the mean, the one-tailed test. Hope you have a great day. Bye.